G'day, Glenn Morris here from the Smart Energy Lab. I'm here on day 2 at All Energy with Guy from Victron. G'day, Guy.
G'day, Glenn. Good to talk to you again.
Now, Guy, I've known you for a long time. You are sort of representing Victron here at the show, but you're actually a global Victron. What's your title?
Well, yeah, that's a tricky one. It moves with me. So my job at Victron is basically to find the pain points in the company at various levels. So I've done all sorts of things. I'm the founder of the Victron community, which is our online portal where people can ask questions and answers. I'm also the online training manager, so I've made training videos for Victron as well. But I also overhauled the documentation inside Victron. I've updated data sheets. I now work on the VRM team, our software management portal, and I'm part of the coordination that's happening between Victron Connect, well, basically let's say call the Victron app, and what's happening with the evolution of the Victron app. So I try and find out, well, what I can do, where I perceive Victron's issues to be, and I do my best to go at it until I can fix it the best that I can. That's my job. So the title is a bit nebulous, really. There's not very clearly defined boundary. It's like, where's the problem? Can I fix it? Go. Do it.
Well, are we standing in front of a problem or a solution?
It is both a problem and a solution. So for a very long time now, the biggest system you could have on a Victron is 180 kVA. That's 12 Victron Quattro 15 kVA units. That's 4 units in parallel on 3 phases. This is a new product that makes a few changes internally, which raises that bar up for us, which is really important because we've had lots of installers that have grown their businesses over a long time with Victron. The market's grown and the demand is growing, and people are beginning to trust renewable power more and more, and power systems like this are needing higher and higher power loads. So this is the new product. This is the MultiPlus-CL. It's a 48 volt, 20 kilowatt unit. So the previous unit was measured in kVA. This is now measured in kilowatts. So the previous unit was 12 kilowatt, 15 kVA. This is now 20 kilowatt. And it makes 2 important changes inside. It looks a familiar case, but the first is the move to an aluminium transformer. So previously we used copper toroidal transformers. This is an aluminium technology transformer. So it's lighter and it's cheaper. That's the 2 important features about it. What that lets us do is also then rebalance the internal of the system and move to bigger FETs. So we can now, that's part of the reason we get to 20 kilowatts. Okay. The rest of the power bridge can be upgraded and better balanced with that large transformer, and we can get more power through it, in a shorter amount of time, so more capacity. Now what that means, that's interesting enough on itself. What that really means though is we can now move to the next level and start to make 240 kilowatt Victron clusters. Yep. And the reason I say clusters is because I also want to introduce you to another very interesting concept that's happening in Victron. No, but it's close. The CL stands for classic, for being the classic case. Oh, okay. But I imagine this will be used in a lot of cluster systems. So if you have any questions about this product, let's do that. Otherwise, I'll take you and we'll talk about clusters.
Maybe I'll just have a quick one. So for those who are not familiar with Victron, this form factor has been around for a long time. With the ventilation on the top here with the cover, it makes it easy to lift too. You've got plenty of hand points on it.
You want 2 people still?
Yeah, still people.
Unit.
Yep. It also has a 2-position on-off switch. What's that for?
Right. So the switch on the front allows you to do inverter mode or purely charger mode. So one of the biggest, it's not a feature now, but Victron, one of the first evolutions of us from our R&D, was the introduce of inverter chargers. So using 1 toroidal transformer and 1 power bridge, the ability to not just invert from a battery through to an AC supply, but go the other way. Take an AC supply and go back into a battery. At the time, that was an amazing technological revelation. And then we could do not just charging and discharging, we could also do what's called power assist, where we could support a small generator to run a larger load using the battery to balance the difference, and so on and so forth, using different balances of power across the system from different sources. That's part of what the core technology of Victron is. We're celebrating our 50th year this year. The MultiPlus has been around for somewhat half of that. So it's interesting technology we've had for a very long time, very robust, and we're still developing it. So we've got exciting features to talk about, what's been the evolution of this product and where it's going next.
So Victron is really the OG of inverters and also all the other ancillary equipment. If it's blue, it's probably from Victron. You'll find it anywhere around the world. It's an incredibly well-respected brand, but you've evolved to something called the cluster. So tell us about that.
Let's head over.
Okay. So Guy, we're standing in front of a wall. You said cluster? What's that about?
Right. So there's been 4 key pain points that I've seen in getting to very large Victron systems that are coming up again and again and again. We're seeing customers who need bigger and bigger load demand, and they're trying to use Victron systems. And the 4 problems they've got. The first, in the existing Victron model, where we've got these very large units, 20 kilowatt Quattros or MultiPluses, you need to connect them all with VE bus. That's our communications cable. And this cable technology has been around for a long time. The problem is each unit needs to be connected, and if any one of those units, which could be 12, fails, the whole system goes down. They need to be synchronized and maintain synchronization through that. So the bigger the system gets, the more likely it is to get interference or a bad comms card or some other corruption of a packet in there that causes problems. That's the first problem we see. The second problem we see is the AC input relay of our units all need to be synchronized if you're trying to connect to a generator. The more units you add, the more relays need to be synchronized, and the bigger the load gets that needs to pass through those relays. It's very hard. As you get more and more of them, it's more likely one of them is going to be a little bit out of time with the rest of them, which means others are doing more or less, and it can lead to failure of that relay if eventually one of them cups most of that current load and can fuse shut, and then the system is in a failure state. The third one we see is that, there's the 200 limit or the 180 kVA limit. I'll say this one, that people have to decide when they're designing the system in the first place, how big do I need it? There's not a lot of flexibility to expand the system beyond that. So working with any large customer, you'll know, often the customer doesn't really know what their load are. Part of the job of being a system designer is to try and draw out from them what are they actually trying to do, and then where are they going, so I can do that in the future. And it's very, very hard to find that right information, size the system properly in the first place, build it bespoke for them, and get there. So this model, this solution, hopefully breaks through all of those issues and solves them all at once. Yeah. What is the last big issue in these systems? Good question. That is a problem. Very high currents. Let's say that. Yep. So each in an existing Victron system, or when you're connecting multiple systems together, they're all at 48 volt. The currents get very, very high, into the thousands of amps, and that's actually a hard constraint. Not only that, they need to be balanced on the DC side. So you need to have all the battery banks lined up, all the same cable runs on the AC side as well, and at some point, because of the physical size of the units, how big the batteries are, how big the inverters are, it becomes very, very difficult to keep all of those runs equal and balanced across all the bus bars and everything else. So that's probably the reason we can't move up to any larger. This solves all of those problems for us, yes. All right, so what this is, it's the new Microgrid function inside the MultiPlus and the GX device. It's available as a new hardware revision at the moment to engineering teams that are willing to work with us. Initially, it's only going to be for the 15 and 20K units. Over time, it's going to be available to all VE bus products. So it doesn't matter what size the inverter is, it can participate in this system. And what it does is in a normal Victron system out of the box, the AC input is never live. So what it does is it looks on the AC input and says, is there a supply there? If it is, can I connect to it? It'll try and synchronize with it. If it can, it'll close the relay, it'll start charging the battery or start running the loads or whatever. What this firmware revision does, and what this technology does, is it looks on the AC input and it says, is there a supply there? If there is, I'll do what I do. I synchronize and then connect to it. And at that point of connection, there's no load on the AC input relay. So it's very safe, very low duty for that component. What we can do here now, if there isn't any AC supply, it will then generate it. It will start and provide and push back in through the AC input. So you need to have the system designed and specified for this application. You can't just apply this firmware and put it into any old system, because that's not safe. But
no socket inlets.
No socket inlets. But where you're designing a microgrid system, then what that means you can do is that any system, there's no master-slave relationship. Any system can start the system up, and at any time you can remove any system, or it can go down or offline. It can participate or not participate, so you can send the states of charge where you want this system to export and where you want the states of charge for this system to import from the microgrid, and different systems can balance the power across them, all using no communications cables. It's all managed through the AC, so it's on frequency and it's on voltage. And just on those parameters, the system can find load to supply across all different disparate systems of different sizes, across different phases. The systems don't have to be the same size, you don't need to have the same systems on the same number of phases, they don't have the same battery chemistry, they can be all different types and all participate in this microgrid structure.
Is this like droop mode?
It's very, very similar to droop mode. It's slightly different to droop mode, but it is very similar and based off the same situation. Droop mode will come as a similar feature in a similar time,
Right. Right, so it's actually like the redundancies built in this design. The fact that every single system is a boss.
It could be a boss if it needs to be.
If it needs to be.
Yeah.
So you're not relying on VE bus for synchronization, and you're not waiting for a input before you start to
You're not
parallel.
waiting for a central controller.
Yep. I guess it just means it's all fixed wiring, of course, because everything has to be permanently connected for that to work. And you can scale it up to 240 kilowatts.
There's no limit to this.
Oh, there's no limit.
This is for megawatts and beyond, this system. Each cluster module can be up to 240 kilowatt. But you can connect any number of 240 watt clusters together.
So you've solved the current problem too.
You can have independent battery banks. The DC bus no longer needs to be connected or synchronized. Each system is independent unto itself. You could have a lead acid battery bank. There's a legacy system that you don't want to touch because you don't want to touch it, but it can still feed into this system from a MultiPlus. You can add a lithium battery bank to it and feed it all through to the same AC. The lead acid battery bank can go down or fail or be serviced, and then you can work on that system. You can add new capacity as new technology comes out.
Well, because Victron's been around for so long, there's a lot of lead acid systems still out there which probably need more storage capacity. So you've basically provided a solution, but currently it's only for the 15 kVA and the 20. So as long as you're in that sort of spectrum.
I'll say to that, at the moment the biggest pain point that we see is the ability to go to larger systems. That's where we need to provide a solution today to keep up with the market. Where this technology can go is all the way through the range, and we have the biggest range in the industry. So all the way from VE bus, very, very, very small inverters. So a 3K watt into it, but it's coming.
So each inverter just needs to connect to the GX device. Is that how it works? Can it be through Ethernet?
So each system will have its own independent GX device. So there's not a central GX device to control it. We'll have to build another layer inside VRM to then connect and bridge those GX devices so you can get a total microgrid system view. That part, we have some solutions already today that work and are fine, but we're going to build a better platform to support that type of layout. But as it is, each system, because if you can imagine, each system has different lithium batteries, those individual lithium batteries need the individual attention of that GX device to properly charge and discharge and manage their own individual system. Each system's characteristic, how much it participates in the network as well, is managed through that GX device at an individual level. So you can decide, I've got an old battery, an old lead acid battery, I don't want to be deeply discharging this. If the system's got extra PV, let me export that to the system, I'm happy to use that. If my lead acid batteries get very low, let me import from the system, that's fine, it'll participate, but it doesn't need to be,
So because the Quattros are single phase, how do you synchronize multi-phase when there's not a VE bus?
So for each individual cluster, if you want a three-phase system, you'll still need to synchronize the three Quattros in that individual system that will form.
Only three.
If you want a three-phase system, you'll need three connected via the bus. That's still the same. That'll form the backbone of the three-phase microgrid.
12.
From there, exactly. From there, you could add parallel. You can still do 12 in the one system, if that makes sense. And where I see it making sense is if a customer had, for say, a container build that they wanted to optimize and just build containers out, and they just build one type of container, but they don't know how big the customer is going to be in the end. Then they can just build the container type and then parallelize those containers up. So the customer might get 3 containers or 2 containers or whatever. They can choose how many they want in parallel in the one container module which they build before they have the customer, and then when the customer comes they decide how many containers they get. They don't have to design the whole system around the end state, which means also if the customer's needs to change over time, maybe they have it on a lease arrangement, they take the container back, the customer's needs go down, or they overestimate it in the first place and there's power going to waste, they can monitor it and see, or power needs go up, they add an extra container into the system and it all works smoothly.
So the $64,000 question is, when is this available?
It's live today in the Netherlands, so there's containers running. I'm going there next week, so I'll see how it works. The last few times I've been there, I go to the Netherlands every 6 months. This year I've been 3 times. I'll go back, and each time I check the progress to get a real sense of how far from market are we. They're already sending out the firmware to field tests and also running this. Where there is, I know, work, like it's working, but where it's not yet production ready, is in the synchronization with synchronous AC generators. We have an external generator, and you need some kind of COM-map controller to manage the generator synchronization with the system. Previously, Victron systems have been slaves to the AC input. Now they can be sort of forming of the AC input. And so then the generator needs to be able to synchronize with that grid form. So then you need a generator that can support that if you want a generator to feed that main AC bus and support it. It's not required, and if you don't require it, it's probably quite a stable solution today. Some good news, I suppose, if you're skeptical or don't really know what's going on. We've got a new training centre at Victron, on the Gold Coast, and we've got 30 MultiPluses coming to that training centre. So we'll build this in real time, and we'll have training where engineers or installers can come from Australia, can come to the training centre, put it together, see it for themselves, make sure it works, and they can start to sell it to their customers.
Wow, that's great to hear. So your own training centre, will you be running that facility or?
Running's a strong word. I wouldn't be running it, but I'll be there.
You'll be there.
Yeah, I'm due to do a bunch of training because, maybe you know, I did a bunch of training videos back in the day, which have been very useful and constructive to help Victron customers. That was based on a series of trainings that I'd done and delivered for a long time. I need to do the in-person trainings, to do the training, to be confident with the material, to work out what customers need, to get efficient with it all. Once I get to that level, then I can create videos and then record a new set of videos.
And do you have a flood-proof studio now?
No, the studio's moved to the Gold Coast. That's the solution. I am working on my property continuously. I have a 10-year plan to raise my house another 2 meters, but that's obviously a big project, so I'll get there. I'm developing my skills.
Well, what else is new? This is pretty exciting stuff, but I saw it next to the new CL, some little boxes on the wall. What were those?
Yeah.
Should we go and check those out?
Let's have a look.
Okay. Guy, are these just a component of a bigger system?
Yeah, I mean, these are very familiar to what we were talking about before. It being an R&D company, you never know what's going to work well or how long it's going to take or where it's going to go. When we had the limitations with the MultiPlus, these products were one of the proposed design solutions to overcome some of those issues. I mean, as you can see from their format, they're different to any other Victron product we've had. They're rack mounted. This is part of a reaction to what's been happening in the industry and the move towards rack mounted batteries and the idea that you want to get the whole lot into one cabinet. That's much easier for everyone. These also have a parallel evolution, a parallel technology in them that was potentially going to resolve some of the issues we had with the previous large format systems. However, there's been delays with the release of these products. The short story is we don't want to release them until they're ready. We have a few other of the RS range. Well, this is the HS, that's the RS. The Multi-RS and also the MPPT RS. Both of those were very much needed in the Australian market several years ago now with the introduction of compulsory earth fault alarm protection. So there were limitations in the Victron MPPT range around earth fault alarms, and we needed to get those products to market as soon as possible so we could still compete and participate, basically. What we've learned from deploying those products to market and other products as well is that our customers really want us to make sure the product is more robust and more ready rather than more available earlier in the product release cycle. So we're taking longer now to make sure that we're fully comfortable. That means more time in the field. So we've got dozens of each of these systems in the field working and using direct feedback with those, not customers, but technical partners, they mostly, sometimes Victron employees in their homes or their other businesses, but we have these relationships with people who are comfortable working with our products to really test them in the field and then work closely with the R&D teams. But as we expand those trials, we roll it out. So it's a different release cadence for us. And a big part of that is the safety. So we've been a low voltage company for a very long time. We're very, very comfortable with 12 volt, 24 volt, 48 volt, and there's quite a big jump up to 450 volt and even 1000 volt, 600 volt in the top end for this larger product.
So I'm very familiar with the RS 450, 100 and 200. I mean, that was a big jump, being able to go up to 450 volts. Yeah. I'm seeing 1000 volts on the front here.
Yeah,
that's already. But
we changed, right?
Are we still at 48 nominal on the battery side or high voltage?
High voltage, exactly. Yeah, and quite high voltage. So a lot of products in the market are at 400 volt. This is 600 to 800 volt on the battery side, which is a early to market, I'll say, entrant to that, even though it's not in the market yet. There's not that many batteries supporting batteries at those voltages. And one of the things to be aware of at those voltages is most battery suppliers, capacity is very large there because they're often supplying 48 volt modules and you need to stack them up in series to get to that higher 600 to 800 volt operating, which means very, very large systems. So in the beginning, this is going to be much more of a proof of concept product, I would say, to get us into this thing. The other thing worth mentioning about this product is 3-phase in one box. So previously, Victron products have needed 3 single-phase inverters to synchronize. In this case, we're moving to a single product which does 3-phase in the one unit.
This is an MPPT.
No, this is an inverter charger MPPT. Yeah, this is not the full depth. It shoots into the wall, in theory. No, that's right.
Wow.
Yeah.
So it's a 15 kilowatt inverter.
15 or 30, they'll both come out at the same time.
Right.
3-phase, with 1,000. Well, again, we'll see what the voltage is. Always check the final data specifications before the product's released, because that's all changing. In PV as well. So a very high powered charger.
Wow, well, this is a big step for Victron. Sort of not leaving behind, but you're moving on from the tried and trusted 48 volt sort of field to going up to these high voltage batteries and rack mounted as well, 19-inch rack mount. It's a very attractive unit, by the way.
The idea that this model of like transcend but also include, like we're not throwing away the past of what we've got here, and because we are experimental R&D company, like we are doing cutting edge research in power electronics and have been for 50 years, we know it's not a straight line. Like some stuff you almost get to the finish line and you realize for X, Y, Z reasons, sometimes totally out of your control, that's not going to be a viable path forward and you need to have another option. So because our customers over time tend to grow with Victron, we need to make sure that we're going to support them in the products they know and love, give them more features as well as we develop it, but also realize that the market is changing, voltages are changing, expectations are changing. We also need to not just stick with an old product range that people like, but also move forward and offer new products in new ranges. And it also keeps it interesting for us.
Well, there's probably a few people out there who've been living under a rock who don't know much about Victron. Do you want to just give us a thumbnail sketch about the history of the company? So
Victron's celebrating its 50th year this year. It's a family-owned company. It was started back then by Reinhard Vader. He needed an inverter, so he was trying to get tropical fish from over in the Algiers. He needed something to operate the pumps and the filters inside his van as he drove the tropical fish back to the Netherlands. He borrowed an inverter. The inverter failed on the trip, and he had to find someone to help him repair it. And on that, he looked at it and figured I could do a better job than that. He was studying physics and engineering at the time, built his first inverter, and then family and friends also started to want inverters as well, and the business sort of grew step by step from there. It's fully family owned. There's no debt. The family owns the entire equity. It's grown year on year on year on year for as long as I've been as part of the company. We've had some extraordinary years of growth. It's now getting to be a large company, but it's still small in terms of how it operates. It's still relatively flat. So basically, I still have direct contact as an individual worker in Australia with the CEO, and there's no other management in between me and them. So it allows us to move very quickly. A big part of my role is interfacing with the market, hearing what's going wrong with Victron products and everything else like that. And I can then feed that back and loop in direct with the engineers. So unlike a lot of big other corporate structures which struggle to move quickly when needed, we can still stay quite nimble despite having over 1,000 SKUs in our product range covering marine, automotive, telecom, industrial, residential, ESS markets, off-grid markets. It's all there. It's a huge scope of company, but somehow, after all of these years with the right people, we've been able to keep it all together and maintain the momentum, maintain the quality, and really build a quality brand.
I think I'll tell my little personal story too. You've heard this one before, but I was communicating with what I thought was a lowly support engineer called Matthias, and he stopped emailing me for a couple of weeks, and I complained to you about it, and you said, Glenn, that's the CEO. He actually does support as well to keep his finger on the pulse. It's pretty impressive that the boss of a global company like Victron actually takes calls and emails from people like me occasionally. Yep. So pretty.
I'll add to that. It's not just impressive that he takes the calls. There is nobody in the world that knows more about Victron than Matthias. He's the only guy who has the biggest view of what we do, and we do a lot. We do our own hardware stacks, we do our own software stacks, we do our own engineering, we do our own firmware, we do our own cloud deployments, we do the whole top to bottom nut stack, and it's a lot. It's a huge amount of stuff to stay on top of. So he doesn't just get involved and dig in. He's the guy. Like if you need a question answered, and then he's the one to know, can we answer it? Do we not or not? Now, obviously, there's only so much you can do in a 24-hour period. So part of the reason why people like me exist is to help find a bridge between what can I find and systematize and scale so that Matthias's time is used valuably. And part of that is interviews and work with you and information on the internet. So people who are active and interested can get the information they want without requiring anyone from Victron. We try and be as open source and available as possible with our information and our training and our specifications. Even some of our software is open source. You can download our operating system. You can run on on Raspberry Pis. We have a huge enthusiast community. So it's a very different way of thinking about how a company operates. But for people like me and our customers, it's really working well.
You do have an amazing support group. I'm on professional.victron.com, and you got a question, there's like 50 people trying to help you. It's really, really impressive. And the wealth of experience of installers too is being shared around there. Yep. Anyway, Guy, thanks for showing us the new cluster system. Yep. I'm really impressed by what that's going to add to the product range. Yep. I'm sure there'll be a lot of people out there with legacy systems going, wow, we can add more storage now. So yeah, thanks very much.
Thank you very much.
Cool.